Hello, hello. I'm Steve Jaguar, one of the many solution architects working at Aqua Security. And in this video, I'd like to show you enforcer groups. No, not those. No, cool and inspirational to an extent, but the enforcer groups I'm talking about are the ones that come with Aqua, and you might already be using them if you've got enforcers deployed. You need an enforcer group to deploy an enforcer. However, do we totally understand everything involved in creating an enforcer group and how we can best leverage those groups inside the product? And there's a lot more to it than I had previously realized. So what I'm going to do today is I'm going to dive in myself and make sure I understand everything about how we set it up and all the different aspects and elements within Aqua where I can use an enforcer group. And then I'm going to tell you so that we can both learn together. So here we go. Here we are again. It all begins with the install. And I've got two different Aqua installations running at the moment. One is from, if you go look at my Aqua install YAML video, this is the same area partway through. Now this is before I have installed any enforcers. You can see I've got the Aqua Web, the Aqua Gateway, and the Aqua Database that we use in POCs up and running. Now I'm going to start with the YAML install, and you could see a little bit of what I do to create the enforcer group in order for me to be able to install enforcers in that detailed video about installing with YAML. But I'm going to pause and hesitate as I go through the enforcer group details and really show you what you can do in there and what they all mean, okay? All right, let's take a look at the GUI. Okay, here we are at my YAML install, and I've got some default groups here. And we can see at a glance the type. The default group doesn't have a type, but actually it's type enforcer by default. The default group for pivotal installations here is of type enforcer, and I've got a VM enforcer group. And at a glance it feels like there's some different types, but really they're all kind of the same thing, and I'll show you that in a moment. Now I need to create an enforcer group to install my enforcers, and I want to tailor it to my needs. So let's go here and create a new group for our enforcers. Now I can already see here there's a drop down at the top. Now this group is going to have an enforcer type, and we have different types of enforcers depending on the context. There's our, let's call it standard enforcer. There's a VM enforcer, which is very similar but only really works on VM hosts. We have a micro enforcer for Fargate and other container as a service environments, and we have a nano enforcer for serverless environments. Now if we click through, we get subsets of everything we might need for an enforcer group depending on what we're choosing and what has the right effect, which is interesting, but it is just a subset. There's nothing necessarily unique about each choice. So the Aqua Enforcer gives us everything. So I'm going to go through that so you get a feel for what everything is regardless of the type you choose. Then I'm going to give it a name. Steve's Enforcers. Fantastic. There's different OS types. We support Windows enforcers as well. I'm going to go with runtime, but I'll switch to Windows briefly so you can see once again we get a subset again of what's possible. So you're going to get the full view by choosing Linux. Within the orchestration types, you can see there's different orchestrators, and different orchestrators mean different things to the enforcer because it needs to tap into the runtime environment. We know that if I choose something like OpenShift, that means I need to pair that up with something potentially like Cryo for my runtime. So there's different information that allows us to create default settings for what we need to do for enforcement. So those are all really important. We also know that things like PKS requires non-privileged access, and Pivotal has an entirely different set of terminology. In addition to a runtime, you can see it automatically is hard-coded to Garden. But again, it is, of course, a subset. So I'm going to go back. So here's my Kubernetes. Now I know that my Aqua service account was Aqua SA, and I know that my namespace was Aqua. So let's just fill those in. Let's leave this as Docker. As we mentioned earlier, we support a variety of runtimes that sit on top of runc. And I've got a logical name. Now I'm going to pause there for a moment. I, for the life of me, could not figure out what logical name was for. But I'm going to fill it in. It's optional. It doesn't matter. But to this day, I still do not know where I can use this. Maybe we should get rid of it. I don't know. I'm feeding that back to R&D. Maybe there's a mission for it at some point in the future. I don't want to leave it out. I like that the gateway filled in automatically, but for the most part, you can just leave that. The installation token. Now I'm going to point that out when we look at the Aqua CTL install. You want this to be unique because your enforcers want to be able to connect back to the console, and in order to do this, they need to do it via a unique token. If I leave this blank, it creates quite a complicated hash-looking thing, that I can then use in my YAML to connect those enforcers back. So it's better than anything my brain could come up with. I'm just going to leave it. I like that the image name is automatically filled in based on the version of Aqua that I'm using already. And maybe I'll create a description. So this is my real default. I'm not going to use the default. I'm going to leave it on audit because I'm not crazy. I'm not going to put it into enforce right away. It's worth also noting here, you actually get some runtime controls built in to the enforcer group that are applied across the enforcers that are created and connected to this group. Now you're probably thinking, allowed Aqua Labels. Okay, well, I didn't do an episode on Aqua Labels, but I will. So I'm going to try and put a link down in the show notes of what those are. But essentially, an Aqua label is like an image label, but it's only existing within Aqua. So if I want to go to my images, I can apply labels and use those labels as part of my scoping to apply different things like image assurance policies or runtime controls, etc. So it's a way of providing oversight labels that are independent of what my developers might do. So I can say only allow Aqua label images that are tagged with a certain Aqua label to run under these enforcers. Now I'm going to leave that blank. That's quite a specific use case. Additionally, say I was going to be deploying these enforcers in a production environment and I have a registry associated with that. Well, I could indicate I've only got 2 registries signed up at the moment via my integrations, but if I had a production registry, I could restrict enforcers within this group and make them block any images from becoming workloads unless they were from a specific registry. So that's pretty cool. You can do that right here. But I'm going to keep this wide open at the moment. But I just want to point out that that's kind of nice. There are other controls within runtime policies that are very similar, but it's kind of interesting that this is here. Okay, there's different tick boxes for different capabilities. And I'm going to focus on all of those right now. Auditing host successful login attempts or host failed login attempts. I don't see any reason to untick these. They are ticked by default. And if you'd like just getting forensics from host activities in our audit log you can see here, that's definitely a plus. So I'm going to leave that in there. After that, there are different capabilities that we have from a Kubernetes perspective that are associated with different capabilities of runtime control. Now by default, we only have image assurance ticked. If I hover over that, you can pause and read that if you want, but essentially it allows a certain set of controls within our runtime policies that are blocking unregistered or non-compliant images. It draws that line from what we do scanning images into runtime so that we have that full lifecycle control. I'm going to leave that ticked. But it would be, I think, remiss if I didn't tick runtime activity, because runtime activity is the real kind of differentiating factor in what enforcers can do within Aqua. And there's a whole series on runtime policies and controls, and there's going to be a separate video on that because there's a whole lot that goes on in there. Now, it would be pointless to not have that ticked, I think. I like to tick system call monitoring as well because that comes into effect if we're talking about profiling running containers. Not necessarily required early on, but no harm in ticking it. There's a small performance hit, as you can imagine, but I'm going to tick it for now. In fact, I'm going to actually end up ticking everything. Let's not beat around the bush here. I'm definitely want to enable network firewall because later I'm going to do a video on how our network firewall works in combination with our entity called services, and that's going to be really interesting because I think there's a lot of fascinating things that we can do with that. I was overusing the word interesting there, wasn't I? I would like to enable user access control because there's interesting things like if I hover over that we can do there in terms of having an ability to create user access control policies. That again is a whole other video. I'm going to enable my runtime host protection. We have runtime controls for file integrity monitoring and blacklisting and whitelisting users and groups. Of course, I want my network firewall to extend to nodes. And I'm going to enable these advanced. I don't know why I don't believe these are really advanced settings. I think, in fact, they're essential settings because I want to be able to discover images on my host and scan and get a risk posture for those. And absolutely, certainly, I want to have my Risk Explorer auto discovery so I get that fantastic view that we can see under Risk Explorer. And if we jump over to this other view where we can see this incredible view of everything that's going on in my world, I want that. There's no way I would not tick that. And I'm not going to get that unless that's ticked. So it's good to know. All right, so I've got everything here. And I can generate this YAML. So if I click Create Group, I'm successful. Nice little bit of reassurance. I can see I've got all the YAML I need to create these enforcers. And this is very similar to what I did in the install. And I'm going to copy that, and I'm going to deploy some enforcers. But that's not necessarily why specifically we are here right now. So coming back to our console, I'm going to edit that, and I'm going to paste in the YAML that we generated and just go straight up to the top and see something that's actually quite important. And that is that we are deploying this as a daemon set. So every node specified by this YAML is going to have an agent deployed upon it. Now, is that necessarily what we're after? Now, we're deploying something for every node that is going to be running enforcement. There might be some things that we want to add into this. Now, I'm not necessarily going to add those, but I just want you to use your imagination. When we're deploying a daemon set across every node that's going to be enforcing risk, we might want to use things like affinity or node selectors or taints to suggest that certain enforcers are applied to certain types of node, whether that be based on the type of pods we're deploying, say if they're determined by storage or logging, or perhaps a certain risk assessment of the host itself, perhaps certain hardened nodes for higher risk applications. So we can start to deploy different enforcers in different areas. And if we're going to do that, we might want to create different enforcer groups to associate those enforcers. If I can apply certain enforcers to certain nodes based on either the application type or the risk or the affinity, then I've got a way of chopping and changing all the different enforcers on all the different nodes in a way that allows me a unique method of controlling enforcement. Now let's go take a look at how we can use that. Back in our console, we can see our enforcers here. I haven't applied them yet, but it's more important that we just know we have this group available. Now, where can I use this entity? Now, if we think about that, I maybe have created a variety of daemon sets that are divided up based on certain node selectors or certain affinities or certain cloud types. I could have my OpenShift cluster and I could have my GCP cluster, and they're all in different spaces. And maybe I've got my development versus my production. And I've got different enforcer groups created for all the different types of enforcers and the different methods I might want for deployment. Well, how I can apply that is interesting. If we start to think about scoping, and this is worth referencing the videos on assurance policies, runtime policies, and firewall policies, because those are areas where we can apply scope. Now I'm going to look at runtime policies, and I'm going to create a new policy very briefly, and I'm just going to stop on scope and take a look at something that's actually pretty critical. I'm going to create a container runtime policy that my enforcers will be enforcing. Now say I want my Steve enforcer group. So these are my high risk, because that's where Steve enforcer is going to go. If I look in my different types of scoping here, and I look at host and group, that's very interesting. And also, if I look at Aqua enforcer group, now one thing that's going to change in a future version is the fact that I have to type in Steve enforcer. I don't really like that. Now, I believe in the next version of Aqua that's going to be an autofill, so I don't have to worry about that. I don't have to worry about making a spelling mistake that makes sure it doesn't work. And you can see I did it again, Steve enforcers, there we go. So watch out for that one. Let's go back over here and I'll create that policy. I like to show warts and all. Aqua enforcer group, Steve enforcers. All right, let's add that. So now this policy will only be applied to that group. Now we can use our imagination. Now we can see that, okay, so if I create an enforcer group that is a daemon set, and I tailor that daemon set to a particular style of node, I can start to create those lines. Now, what I'd like to point out is if I say and, by the way, you can use logical entities here, host group, Steve enforcers, same thing. A host group and an Aqua host group, you can see, you can kind of catching on here, right? They're the same thing. It's just a different type of wording. I found it a little confusing that this wasn't called enforcer group, and yet this was called enforcer group. So I looked it up in our documentation, and it turns out it's the same thing. It's an enforcer group. So you don't have to get confused about it. That's one of those things that happens. So that means the same thing. So I can just leave that out. But what's kind of exciting about that for me now, as someone who's deploying Aqua, is I have this new method. And it also works if I'm talking about firewall policies. And again, although that's a different video, I just want to show you very quickly. If I go over here and I add a service entity, which is essentially an overloaded term, right? Well, I can see I've got this scope again. So if you can imagine services, and this is a subject for another video I've definitely got to cover, services are used to create firewall-based entities for creating rules, and those rules are independent of, be that Kubernetes entities like namespace, container-based or Docker-based entities, just like container names or workloads. But they're based on scope. And we can see the depth and breadth of the scope is quite interesting. It's very similar to runtime policies. So if I wanted to ensure that my Aqua enforcer group, Steve enforcers again, can only communicate as a service to another enforcer group. So that could be from Google Cloud over to Azure based on my enforcer group distribution. I could create rules using services based on scoped enforcers. So that's another bit of food for thought based on the combination of enforcers and scoping. Okay. I don't know about you, but I learned a lot there. First thing is that you always have enforcer groups, whether you realize it or not. If you do the YAML install, you use it to deploy the enforcers. If you're doing Aqua CTL, there's a default one created for you, and it doesn't matter what's happening, whether you're using Helm or Terraform or whatever you're doing, you're going to need an Aqua enforcer group. And when we dive into the different parameters, we see that we can even get a little bit of runtime enforcement there in terms of registries and labels. We are enabling and disabling certain capabilities within that group. And in a way, an enforcer group is kind of a class definition to the enforcer object, as the different enforcers inherit all the capabilities within the group. Cool. But what was more, I guess I don't want to say exciting, but fascinating about enforcer groups is that we could use these within the scoping of runtime policies, be that the standard runtime policy or even firewall policies with the definition of services. So that was really interesting when we use our imagination and combine that with the fact that we're deploying enforcers as a daemon set. We can use some of the Kubernetes native elements like affinity and node selectors to make decisions on how to divide up our deployment of enforcers and use the enforcer groups as scoping, whether that be against a cloud type, a certain purpose, be that dev versus prod, or maybe even the type of pod that we want to be already deploying onto a particular node, maybe a hardened node, or let's call it a softer one. So there's a lot of scope for flexibility in the way that we're going to be applying our runtime enforcement with enforcers, thanks to enforcer groups. I'm Steve Giguere, a solution architect with Aqua, and I hope you enjoyed that video, Enforcer Groups. Hey, DevSecOps fans, if you like podcasts, why not check out mine? It's called BeerSecOps, and already I've had interviews with Gene Kim, Kelsey Hightower, Liz Rice, Michael Hausenblas, and the list is going on and on. So, if you're on lockdown like I am and you're looking to kill some time via audio, check it out at all good podcast sources.